Let's verify whether this given transformation from R3 to R3 is a linear transformation. To do that, these two conditions should be met. The first condition is that using vectors u and v, the first condition is that the transformation of their sum must be equal to the sum of their individual transformation. This is the first condition that should be met. Again, the transformation of the sum must be equal to the sum of the transformation. The second condition is with a certain scalar, the transformation of a certain scalar times vector u must be equal to the product of the same scalar and the transformation of the same vector u. So we have here these two conditions that should be met. Of course, we will define here our vectors u and v. Since we have x, y, and z here, let us use vector u for the sub 1s, x sub 1, y sub 1, z sub 1. And our vector v for the sub 2s, x sub 2, y sub 2, and z sub 2. Okay, so let's start verifying the first condition if this is satisfied. So you have here the transformation of the sum. And we need to reach the sum of the transformation. But of course, let's substitute first the let's substitute the entries for or components for u and v. So you have here for u x sub 1, y sub 1, z sub 1 plus x sub 2, y sub 2, and z sub 2. When you add them up, you will have x sub 1 plus x sub 2. Alright. Then you have here y sub 1 plus y sub 2. And then z sub 1 plus z sub 2. Since we already have three components now, let's now apply the transformation here. So basically, we're just going to use the third, the second, and then the first component for this. So you will have to start with z sub 1 plus z sub 2, y sub 1 plus y sub 2, and you have x sub 1 plus x sub 2. Since there are no other terms that can be added or something else, so let's separate the two vectors using the sub 1s and the sub 2s. You have z sub 1, y sub 1, x sub 1, plus you have your z sub 2, y sub 2, and then x sub 2. Take note that this too follows the same transformation zxy, zxy, zxy. The only difference is that for the first form here, we have sub 1s that corresponds to your u. That would mean this is a transformation of your vector u. Plus, your second would have sub 2s, that's the component for your v. This is the transformation of vector v. See that we arrived to this, okay, from this form. And this means our first condition has been satisfied. Okay, that the transformation of the sum is equal to the sum of the transformation. Let's proceed to the second condition. So let's have C be any scalar. So you have here the transformation of C, and let's use vector u. When substituting the component of u, you will have x sub 1, y sub 1, z sub 1. Okay, that's z sub 1. So once multiplied, you have c x sub 1, c y sub 1, and c z sub 1. Then we apply the transformation. We start with the third entry, c z sub 1, c y sub 1, and we have c x sub 1. All of them has c, or if you would like to, you can even write like this: c times z sub 1, c times y sub 1, c times x sub 1. But of course, they are just the same because this is multiplication. Now that we have c on all the components, we can take it out. What's left here is z sub 1, y sub 1, and x sub 1, which corresponds to this here. This is your transformation of your vector u. Together with the c outside, we have satisfied the second condition, that the transformation of c times a certain vector u is equal to the product of c times the transformation of vector u. With these two conditions have been met, we can now say that the given transformation is a linear transformation from R3 to R3. Thank you very much for watching.